In this video, I wanted to take a minute to go through the difference between a compiled programming language and Python, so that you can kind of at least see how the same application might look in two different things. Now, the application on the left is a Rust application, and the one on the right is a Python application. I did change the one on the left because I wanted to show you there's multiple ways to do the same thing, but technically they're both about the same. Now, before we get started, what I want to do is I want to go up here to the top and let's talk a little bit about the languages, just so you can see that no matter what language you want to learn, it's fairly simple to teach yourself once you get the basics. So one of the things that we had to do in Python is we had to import our random package so that we could then call the random function. It was not part of the core Python, so we had to include a library to be able to do that. And in Python, you do that with the from keyword. So you say from random is the name of the package, and then we're going to import, and the asterisk stands for everything. So we're going to import every part of that package. Now, if you jump over here on the left, this is how you do it in the Rust programming language. You use the word use. The name of the package is rand, R-A-N-D. The double colons are there to tell it that we don't want the entire random package. We only want the RNG part. And so it lets you break up the package and get sub packages or sub routines, sub functions that are related to that particular package. So the two colons are just telling it to get anything. If I only wanted to get the entire random package and not care about the individual things in it, then I just leave the two colons and the RNG off, and I would have had the same thing as what I have over on the right. Now, you'll also notice that every line in Rust ends in a semicolon, and you'll also notice these open and closing braces. And this is one of the things that I was mentioning in Python that kind of drives me crazy, is that Python has no braces. And so they determine what is part of something else based on the spaces that are in the line. So if you look over here on the right, you have a if statement here, and it says if operator equals 0, and then you put a colon on the end of the if statement to tell it that's the end of the if statement. And then we have spaces here to tell it where what is part of that if statement. Well, if you look over here on the left, what we do to do the same thing, and I'll use this for statement as an example, just pretend this is an if statement. But we have braces in here that says that this is the beginning of our block. And if we jump down here to the bottom, there's the end of that block. So it gives us a definite way of seeing what is the beginning and ending of a block. I don't have to worry about spaces. In fact, if I were to come over here, let's say this if statement, and I backed it all the way up, this would still work, because Rust knows when it goes to compile the language that this is still inside of this for block. At the same time, you'll notice that I have open and closing braces on the same line. Well, it still knows that that's the way this looks. So if I were to come in here and do this like I have the other lines, so we just break this thing here and then move this thing there. So this is the same thing as what most of the other code looks like here, but it doesn't matter. The Rust compiler knows that those braces are there, and since this is on a single line, I just threw them all right here together to clean up the code a little bit. Now, one of the things that you'll notice here is that because there are no braces on the Python, the line count on the Python program is pretty short. Because as an example, this for loop right here happens to match up. Let me get down here to the bottom, and I'm going to explain this in a minute, but this for loop matches up to this for loop. If you look, it says in the Rust, it says for x in 0 to 5. If I look over on the right, it says for x in range 1 to 6. Well, those are really the same thing. They're looping 5 times. So if I look at the for loop, they're pretty similar. The one on the Python has a colon on the end to tell it that that's the end of that for, or that's the beginning of the for loop, the end of that line. And then looking over here in the Rust, we just have a for, and then I have an open brace down here underneath it. Now, I'm going to show you the way that most programming languages, the way the programmers actually make all this stuff look, is they would actually do something like this. So this is the way most programming is done. They would have the if condition, they would have the open brace here, they'd have all the code indented, and then the closing brace would line up with the if statement it goes to. The problem that I have with this, and there's a few different problems that I have with it, but one of the problems that I have is that because this open brace, and let me say one thing first. So in Swift, Rust, Go, and maybe a few other languages, they force you to put the open and closing braces. Anytime you have more than 2 lines that are going to get executed as a result of that if statement, you have to have the braces in any language. But if you only have 1 line that you need to execute, Rust still forces you to put the braces. And so what it causes is it causes some extra spaces in your file, which adds to your line count. So if you look up here, or look right here, to give you an example, this match statement that I have here, which we have if statements over on the right, it takes 15 lines of code over on the right to do that series of if statements. If I look at Rust in its current form, which is the way I like to format it, which is the braces are lined up with the code and everything is indented, then I have 30 lines of code. If I do it the way that most programmers actually program it, I would have 23 lines of code. So I save 7 lines of code in this particular match statement if I were doing it the way that everybody else does it. I just prefer looking at the code like this because it's much simpler to me to visualize. Because what this particular code, for example, would look like is we would end up with our open here, these guys would be here, and this guy would be here. And so you can see here that my 1 and my brace kind of line up with each other, and it just kind of clouds up what I'm looking at. And I've got other reasons that I do it this way, but we won't get into all those right now. This just happens to be the way I like it. Now, here's the thing. In Python, I have to have everything lined up with spaces. It has to be the way it is. In any other language, you can literally do this stuff any way you want. So as an example up here, I had this looking like this, and it's perfectly okay. It's 1 line of code, and it has my entire if condition in it with actually 2 lines, but because my lines end in a semicolon and my braces cover up the whole block, I can put them on 1 line if they fit. So that's one of the things that I prefer about most of the other languages. I don't like not having these braces because it just one little space that gets off and your whole program breaks. Now, another difference here for Rust is that it is a compiled language. Now, what that means is that when I'm getting ready to run this, I actually have to compile the program, and the compiler goes and looks for problems. And so it kind of helps me debug the application before I actually even run it the first time. Where Python is an interpreted language, which means that it essentially goes to the top of the file and starts reading to the bottom of the file. And that's one of the reasons, if you remember, we had to put our functions at the top of the file because they have to be read first so that when we call them later on, the system knows that they exist. Otherwise, they won't work. Well, if we take a look at this Python and I jump down here at the bottom, you're going to notice that there really, other than me putting all these hash marks here, there really is nothing here to tell me that this is the main part of the program. And looking up here, there's nothing really obvious that this is the end of a function. It just happens to be the end of a function, but I can't really easily see that by just looking at the code. Where if I come over here to the Rust program, you have a main function, which is the main function. most programming languages, when you start running them that compile, they're going to have a main function. That's the starting location that's going to kick the whole thing off, is called main. And so it's easy to go to where that happens, wherein you can see in the Python, it's a little bit more confusing as to exactly what's going on. And then if I jump down here to the next function that's here, we've got a do algebra function here, and it's, you know, fairly obvious what I'm working with. And because I have braces on the ends of them, I can easily see that this is the end of a function here because there's a brace sitting out there by itself. So it's a lot easier to manipulate the code and work with, in my opinion. Now, the other thing about Python is that because it is not what's called a strongly typed language, you'll notice that there are things in here like exit equals false. Well, that's declaring a variable and we're setting it equal to false, but it's just, I can turn around and set exit equal to Glenn and it'll just become a string. And so that kind of a problem, you're not going to catch that until the user is actually using your program and things start to work wrong. And then I got to go back and try to figure out what the heck is going on. Where in a compiled language, the compiler will actually look at the type of variable. So if you look up here, we're telling it in Rust, you use the keyword let to start defining a variable. The MUT tells it that it's a mutate. It's a mutable variable. So mutate means to change. And so what we're saying is that by default in Rust, you can't change a variable once you set it to something. Well, in this case, I need to be able to set exit to true and false. So I need it to be able to be changed. So I use the keyword mute to tell it that this is a mutable variable or a changeable variable. And then I'm also telling it that it is a Boolean. So that's the type of variable that we're defining, and we're going to go ahead and set it equal to false when we define it. And so now the compiler will not let me put Glenn in the variable exit because it knows that that is a Boolean type. It's not a string type. And so everywhere that you see the keyword let, and then you see these variables and stuff down here, this is where I'm setting them. So as an example, this is an integer, 32-bit integer, and that is all I can put in it, is a number with no decimal places. Somewhere else in the code, you'll see some float 64s, which means that that variable can hold a float value. And it also means that I can't take one variable and do something with a different type of variable unless I typecast it. I tell it that, look, I know this is an integer, but I want you to treat it like a float for right now. So there's a lot of things in these languages that you have to learn, but they're pretty much the same. Once you learn how to do a for loop over in your Python, you'll be able to jump into a new language, look up the word for or for loop in Rust, and then you come in and do this. So to be clear, I didn't know how to program in either of these languages when I wrote this code, but I could easily do it because I knew what a function was. I knew what a for loop, I knew I needed a for loop. I knew I needed a switch statement. Well, if you remember in Python, there is no concept of a switch statement. So in Rust, it's called match, but it's the same thing. I'm telling it to match on this variable, and that variable happens to be right here in the for loop. So I'm saying if x equals 0, I'm going to, and that little arrow just says I'm going to execute whatever code is over here on the right. And then I have a comma, and I'm telling it if it's a 1, then do this, 2, do this, 3, do this. So all that does is it gets rid of all these if statements. So it just has a single match statement or a switch statement that goes through and matches everything up. Now, in Rust, the match statement is a lot more powerful than a typical switch statement. So I'm assuming that's why they renamed it to say match instead of switch, but that it is a little bit different, but it does the same stuff. So but you can see looking over here that we have this all these if statements right here, and then look at how much space it takes with my formatting. It would be 7 lines of code less if you actually put that opening brace up on the line above it. But it's, you know, with my formatting, you can see the difference between the lengths of the code on the right and the lengths of code on the left. And then you'll also notice that all the lines end in a semicolon, and they all have their braces around them to say that this is a block. So, but again, once you learn those concepts, you can pretty much do this. Now, I'm not going to get into a whole lot of depth as far as what I did here in this Rust application, but I wanted to take a second to show you that there are multiple ways to accomplish things. So in the Python program, you can see that we have a while loop. We're telling it while true, and then we're telling it if the correct answers are greater than or equal to the number of questions, then we're going to break out of the code. Otherwise, we just start looking and we say if x equals 1, then we're going to do this. If x equals 2, do this. Well, if you look over here in the Python application, we're in that for loop, but instead of calling a bunch of different functions, we're only calling one function. So the function is coming in here and telling it to call math practice, and it passes it x. So it knows, if you look up here, if x is 0, then we're practicing a multiplication tables. If x is 1, then we're practicing addition and subtraction. 2 is multiplication. 3 is division. 4 is algebra. And so each of those things is going to get passed into this function. That function has a return value on it to hold on to the return value, and we're calling it res. And if we look up here, we can see where we defined res, and it's right here. It's an int 32. And so that's all that's happening. So we don't have all of the different functions that are getting called over on the right. We just have one function. Well, let's take a look at that function. Now, another thing you'll notice is that function is actually under my main. In a compiled language, it doesn't matter where you put those functions in the code, because it always goes to main to start off, and it just goes and finds main and takes off. It doesn't need to know that all these other functions are there because it compiled it and it already knows. So let's take a look. Here's our math practice. The first thing to notice is that in Rust, we use the word fn to denote that this is a function. If you come back over here to Python and we take a look, it's called def. But if you look, they're very similar. We got math practice, that's called add and subtract, open and close parentheses, and then a colon. Well, you'll notice there's no return type on the Python, even though we are returning something. And the reason is because it doesn't need it in Python, because Python is an interpreted language, which means that the system is actually looking line by line at what you're doing to decide what it's going to do. And so when I declared these variables, it just goes out and declares the variables and uses them in ints. But again, I can turn them to strings in a minute if I wanted to, and Python he wouldn't care less, even though it would totally break my application. So if we go back over here, we have our, this line is just defining our random generator so that we can actually use it to generate random numbers. Q is a string that we're going to use to build up our question. There's our operator, same as what we have over on the right, to determine whether we're doing addition or subtraction. And then we've got our first and second numbers. And then here is where we set first and second number to be the random number. So that generates us a random number. But then if you look here, we've got some weird code going on, because we've got a match, and we're telling it to match on section. Well, what is section? If we come back up here, section is what we're passing in. So it's 0, 1, 2, 3, 4. So that's what section is. So we're telling it if it's a 0, that means we're doing our multiplication tables. And if you remember from our multiplication function, we didn't want to get a range up to 99,000. We wanted to only go to 12. And so what I'm doing here is I'm overriding what up here we got a random generator number to 99,000, but here I'm saying that I only want to go to 13. So I want to go from 1 to 13 for my random numbers, which gives me 1 to 12. And there's my second number as well. So that'll give me numbers up to 12 times 12. It'll be the biggest numbers that it can give me. And then I build my question. So this is where I'm actually formatting my first number plus or minus my second number. And you'll notice here it's got a multiplication. So here I'm building my string, and here I'm actually putting it in there. And so that's all I'm doing. Add and subtract, we wouldn't have executed that code, so the random number would still be 99,000 to 99,000. So all I'm doing is building my plus or my minus based on my operator. And then we come down here to format our multiplication, which is pretty straightforward. And then we have our division. Again, division, we want to make sure the number on the left is only from 1 to 10. And so we've got a little bit different range there. We've got our second number, which technically we don't need to have this second number because we've already generated it from 1 to 99,000 above. And so again, we build our question. Then we come down here and we print our question, which is going to show us a question. And then we start to look for input. So right here, these 3 lines are me defining a variable that I'm going to hold for the input. Again, in Python, I don't have to do this because as soon as I say a variable equals something else, it just goes ahead and declares the variable and sets it equal to whatever I said to set it to. So it's not, it's not intelligent at all. It just does whatever the heck you tell it to do, and there's no way for the computer to help you to make sure you're using that variable correctly as you're programming the program. So in a compiled language, we've got that extra assistance, but the downside is I have to specifically tell it what type of variable I'm creating. So this goes out and gets the input from the user. And then this line is doing nothing but stripping off the carriage return, because if you think about it, you're going to hit 22 enter to have that get taken back. And so this is telling it to take that enter key off the line when it gets it. So it pops that enter key off of the string. So I'm left with just a number. So then we do our Q and Q things like we did in the Python code. And then down here, we're just telling it to set that answer of S. We're just telling it to go ahead and unwrap it, and if it doesn't have a number in it, remember we had to do a try catch or a try except in Python to catch this. Well, in Rust, we're just telling it to unwrap this, and if it doesn't have a valid number in it, to just set it to 0. Then we define our Booleans, and then we start looking for the answers. And the only things we really care about here is we've got section 1. So we're saying if we're in section 1, we need to look at the operator so that we can know if we're doing adding or subtracting. And then if it's a section 2 or 0, which would be multiplication tables or multiplication in general, then it just looks to multiply the numbers together. And then if we get down here to number 3, it says, well, this is division. So in this case, we've got to do a little bit more work to convert this integer number that we had into a decimal number, and then we divide them and then do a round to be able to get the number we're looking for. Now, what this code's doing is round in Rust strictly just chops off the decimal. It doesn't care about anything else. It just whacks it off. And so what I'm doing here is multiplying it times 1,000, which is going to move the decimal 3 places to the right. And then I'm going to chop it off, and then I'm going to divide by 1,000, which will move it 3 back to the left, which will give me a round of 3 decimal places. And I do the same thing here to get my correct answer. Now, one of the things that's a little bit different here that's kind of cool, and you can probably do this in Python too, I just haven't looked it up, but I'm actually coloring the output. So as an example, when we go and run this application, and it says 11 times 9, so we put 99, enter, and you'll see that it says good job in green, and then it's got our answer stuff here in blue. So it's just a little, adds a little bit of flair to it. And also I added some code to put a line above the problem when it goes to ask the next question. So the point here is that the code between the two is completely different, and yet it actually does exactly the same thing. And so there really is no one way to do everything. You literally just learn the functions and the processes, your try catch or your try excepts, your how do I define a function, how do I multiply, how do I divide, how do I round, how do I do an if statement, an else, all the few things. There's probably 25 or 30 things that you got to learn about how you do things. And then you're just a matter of looking up functions and things that you can call to do whatever it is you're trying to do for your application. So the learning aspect of going from one programming language to another is usually more caught up in, the language specifics, like being able to, or having to declare variables, where over in Python I never do. Things like that takes a little bit of time to get used to. But overall, the core concepts that you're learning in Python, you can move into developing iOS apps, for example. That's the Swift programming language that you would be using in that situation. And the only downside to go in Swift, and we may get into that at some point, but right now I'm trying to keep it down to the core programming aspect of learning to program, because once you get into Swift, it gets really frustrating because you're having to deal with the user interface. You're having to learn how to put controls on the screen, how to get input from them. There's just a whole lot of complexity that comes along with that. You can learn it on your own because, again, you're still using functions, if, while, for. All of these things are still there. There's just more of a different flow that you're going to have to learn to do the more advanced programming. So right now we'll stick to Python, but I wanted to show you a little bit different way of accomplishing the same thing that we did in Python.